In this video, I will show you how to take an angle that is given in radians and make a sketch, identify the quadrant, find the reference angle, and state a coterminal angle that is within 2 pi. So first of all, let's do the sketch. Now, if you put 7 divided by 6 in your calculator, you're going to get about 1.2. So this is approximately equal to negative 1.2 pi. That's all the information we need to figure out which quadrant the angle will fall in. So remember that we will always draw the initial side of the angle on the positive x-axis. So there's the initial side. Because this is negative, we are going to rotate clockwise. So we're going to go more than pi, all right, because negative 1.2. So if I went to here, so far I've gone negative pi. Now if I went all the way around to the positive y-axis, that would be negative 1.5 pi. So I know it's going to be somewhere in this quadrant, quadrant 2. So my terminal side will be somewhere in quadrant 2. So that's the main thing, is to get your quadrant right. And then I'll finish drawing my path. Okay, so there is our sketch. So obviously this is in quadrant 2, so we will go ahead and state that. And now it's time to find the reference angle. So please understand that the reference angle is the shortest path from your terminal side to the x-axis. And reference angle is always positive. So this is going to be the reference angle right here. Now, looking at the denominator, I can see that this is one of my special angles. And we'll talk about this more later. But as I go throughout this test, I'm going to be assuming that you have this chart memorized. So if you have not memorized this chart, pause the video and memorize this right now. You should know all 9 of these facts. But these 3 angles are special angles. So if I see a denominator of 4 or 6 or 3, I know that that's a special angle. And so the reference angle is easy. It's just going to be pi over 6 in this case. Okay, so let me see if I can see any more of these. So the reference angle here is just going to be pi over 3. The reference angle for this would be pi over 6. This would be pi over 3. The reference angle would be pi over 4. Okay, so if it's one of the special denominators, you really don't have to do any calculations. You can just see immediately that the reference angle will be pi over 6. Alright, let's talk coterminal angles. Now, so we want a coterminal angle between 0 and 2 pi. That means it has to be positive. So a coterminal angle just means another angle that has the same terminal side. So in this case, we're just talking about an angle that goes in the positive direction instead of the negative direction. Alright, so this purple angle I just drew, that would be a coterminal angle. What is that? The easiest way to find a coterminal angle is to add or subtract 2 pi. Alright, because adding 2 pi will just take me all the way around and back to where I started from. So that will definitely be a coterminal angle. So if I want to add 2 pi, I'm going to need like denominators. So I will have negative 7 pi over 6 plus 12 pi over 6. And that's going to be 5 pi over 6. So that is the name of this purple angle that I temporarily drew. Okay, so that's it for problem number 1. Let's do the same thing for problem number 2. Again, take 17 divided by 7 and put that in your 4-function calculator, which is the only kind of calculator I would let you use. 17 divided by 7. Okay, so I'm getting that this is 2.4 pi. Okay, so this is going to be more than one spin around the circle. So let's go ahead and draw our axes for the sketch. Okay, so as always, our initial side has to be the positive x-axis. This time we're going in the positive direction, so we're going to be rotating counterclockwise. And our angle is more than 2 pi. So that's 2 pi so far. So I'm going to go to 2 pi and I'm going to keep going. Now, half of the circle would be pi. So a quarter of the circle is pi over 2. So I've gone 2 pi. If I went another 90 degrees, if I went to another pi over 2, this would be 2.5 pi up here. So I want to stop at 2.4 pi, so I don't want to go that far. That means I'm going to be in the first quadrant. So I'm going to go ahead and draw my terminal side in the first quadrant. And then I'll finish drawing my path. Okay, so there's a nice sketch. And as you can see, we are in the second quadrant, which I believe is what they want us to put in this column. Yep. Alright, now in this quadrant, in this column, we're supposed to say the reference angle. Now, 7. That denominator is not one of my special angles, so I'm going to have to do some calculations to figure out the reference angle. So remember that the reference angle is the shortest path to the x-axis. So this purple angle that I just marked is the reference angle. I just need to figure out what that is. So here's what you should do. Understand that as we were going around the circle, we went all the way around and we passed 2 pi. So this, I'm going to think of this as 2 pi because I want to find the shortest path to the x-axis. But if I rotated my way back to the x-axis, that's not 0, that's 2 pi because I came all the way around and passed 2 pi. Now if I backed up, I'd be going back to 2 pi, not 0. So this is, I'm going to think of this as 2 pi, and of course this terminal side is the original angle that we graphed. So this is 17 pi over 7. So the reference angle is going to be the difference between these two. The difference between 17 pi over 7 and 2. So if I want to find the reference angle, I just need to subtract. So I will do 17 pi over 7 minus 2 pi. Okay, I will need like denominators, so that's going to make 17 pi over 7 minus 14 pi over 7. So that's going to make 3 pi over 7. So that will be the reference angle. Okay, that's also going to be a coterminal angle. Alright, that's also going to be the answer to the next box, 3 pi over 7. Alright, it doesn't always turn out that way, but this reference angle is an angle that starts from the positive x-axis and rotates and lands, and it's within 2 pi. It's less than 2 pi. So this actually is the coterminal angle as well. So I got 2 for the price of 1 on that one. And think about it. Think about how we find coterminal angles. The easiest way to find a coterminal angle is to either add or subtract 2 pi. Well, just by coincidence, we were in fact subtracting 2 pi. So we were doing exactly what we would do to find the coterminal angle anyway. So that worked out nicely. All right, let's keep going. Let's do problem number 3. All right, this one's going to be relatively easy. It should not take much thought. Okay, there's our initial side. Now we know that pi over 3 is a third of pi, so that's definitely going to end up here in the fourth quadrant. This is negative, so understand that I am rotating clockwise. Alright, a third of pi. So that's my sketch, and as you can see, I'm ending up here in the fourth quadrant. As far as the reference angle, it's just going to be pi over 3. Okay, that's a special one anyway, so as soon as I saw that 3 in the denominator, I knew that the reference angle would be pi over 3. Okay, now coterminal angle. So the easiest way to find a coterminal angle is to add or subtract 2 pi. Since this is negative, I'm going to add 2 pi in order to get a positive coterminal angle. So I need to like denominators. So kabam. So now I'm going to have negative pi over 3 plus 6 pi over 3. So that's 5 pi over 3. Okay, that would be a coterminal angle. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.